All right, welcome. As we get in here and get ready to go, I've got the microphone here, going to get set up, but get it out of the video. There we go. And there's a chat window and a Q&A. If you guys could give me just a signal or put something in the chat if you can hear my audio quality okay, just so I can verify. All right. Thank you very much, Andrew. So why don't we go ahead and get started here? And as a lot more people are getting connected here. Today's webinar is your roadmap for a high-speed, high-quality DevOps process. And the audience and by the profile, most of us here today are executives or team managers, or the architect, or somehow you are leading a software group. And in my 21 years of professional programming and leading software teams, that's a big job. That's a really big job. And there's so much content and so much training and so much out there for the new framework, the new tools, the new technologies. But even though there's some key books about process and DevOps and automation and how to bring quality and speed together and how to put all those pieces together, there's not one holistic handbook to say just do it this way. And so that's what this webinar is about. It's your roadmap for the high-speed, high-quality DevOps process that we're all looking for. None of us want problems in production. None of us want project delays. None of us want big defects or failures. And so we're going to be talking about that process today. Okay. And Rain, go ahead and hide your video, and then we'll keep going with the webinar. All right. So let's move on and just do a quick introduction. All right. So I'm Jeffrey Palermo, and I'm the chief architect of ClearMeasure. And a little bit about us, and we'll blaze right through this. We're a DevOps-centered software engineering company, and what that means is that we aim to help our clients move fast, build smart, and run their systems with confidence. There's two practices within our company. There is one practice where if companies that don't have their own teams but need one, we build one custom for them and we operate it for them with all of these processes and practices and techniques. And the other practice that we have, and this webinar is focused on, is that you have a team and you want them to move fast and you want them to build smart and be able to run the systems with confidence. And we enable that team to do it. We equip your team with the skills and tools and practices in order to do that. So the elevator pitch for our company is this. We're a DevOps-centered software engineering company that specializes in Microsoft and cloud platforms, and we can help you create a well-run software factory to better connect with your customers, and it'll enable you to move fast, build smart, and run with confidence as a team and as a business. And our vision for you is to be world-class at serving your customers through your software, to be absolutely world-class. And it doesn't even matter if you're a startup company or a small company or mid-market company, or if you're a department within a well-established Fortune 500 company. We all have the same challenges, and you want to be world-class. And you don't want to set your team up for the death march or failed releases or even moving slow. So a little bit about the world that this lives in is here's an assumption for us. The software is, and let me fix my video, make that better for you. Your software connects your business with your customers. And we understand that in today's world. Now, 20 years ago, that it wasn't that way. In today's world, that's really what happens. The software connects you with your customers, whether it be a customer portal or any type of servicing to the customers. It really is in the middle of everything. And so there's some common challenges. Some of you may look at this ball of rubber bands and say, yeah, that looks a little bit like my system. And even if it's not, there's a lot of challenges and pain surrounding growing the software system, operating the software system. As you change, there's things that are impacted. As you communicate what's changed, you have to know and how to do that. So this is our model for DevOps. And DevOps, there's a history that goes back to a conference in 2010 where the term was coined, but it kind of leapfrogs off of the Agile movement, which was really defined in 2001. And in some cases, DevOps is talked about as the bringing of development and operations back together. And that's true in Fortune 500 companies or well-established organizations where the divide is pretty large, where you have a development group and they are used to throwing something over the wall, but then the IT team, IT operations group is responsible for actually running it in production. And that started back when we had mainframe terminals. Before mainframe terminals, you were the programmer and you were also the user, or maybe there was one dedicated user who also knew a little bit of programming. But with the multi-terminal, remote terminal mainframe, it enabled multiple people to be on the mainframe at the same time. And so one person could run some code that would essentially take down the mainframe for everyone else. And so thus, the IT operators were born, because it became somebody's job to protect the computer, protect the server from any one of the users doing something that would deny service to the other users. And so from that point on, we've had people whose job it was to keep things running. But in today's day and age, we've seen that process break down, and the whole process is coming back together. There's a hyper-convergence happening, so that effectively we're going back to, hey, if you build it, you run it. That's what DevOps means. And a lot of times, you may have customer service and you may have tier 1, tier 2, tier 3, but it's all coming back together. But I want to talk about the model holistically for doing DevOps effectively and moving fast with high quality. Okay. So there's some common software challenges that this model addresses. I'm gonna go through each one at a time, but we have maybe your business is growing and you need to run at a fast pace. Your system is increasingly critical to operations. Maybe it's growing in complexity. Maybe it's error prone, or maybe you are dependent on a particular person, or maybe you have a particular person who would really love to go on vacation, but they are the only person who can do a certain thing with the system. And perhaps when you do deployments, they're painful or disruptive, or you can't figure out how to do zero downtime deployments. You hear people are deploying in the middle of the day, but you still have to take your whole system down to do deployments. And of course, then you're trying to find off hours and things like that. But the value that this brings is the ability to do rapid, continuous delivery of software changes, increasing the quality, increasing the reliability and the security of the software. Your team would have more bandwidth to deliver new features instead of bug fixes or fixing things that are broke. You're going to eliminate your downtime, and you're going to have happier customers, happier stakeholders, both inside and outside your company. So I'm going to go through each of these layers in detail. But the themes here are moving fast, and you can read what's on the screen. I'm not going to go through it in detail, but the analogy is an assembly line, because that's what this is. We have an idea for a software change, and we need to move it through out to production so that our customers can be using that idea that's imbued into the software. And there's a chain of activities that have to happen. And so all of the concepts along the way of lean manufacturing and Kanban and Scrum and single piece flow, that it's all the same type of thinking. It's as you put together your series of workstations or swim lanes, you're moving an idea for a change through to definition, and then writing some code and then verifying it, and then ultimately getting it downstream to an environment that people can use. And we also want to be smart about that, use the right skills, the right architecture, the right methods, and then we want to operate it with confidence. The new word in production software is observability. Okay, we've probably heard of security, reliability, testability, but in production, we're looking for observability. Do we know exactly what the software is doing at any given time? Do we know what our users are doing at any given time? Do we have alerts when someone just went back and forth trying to do a particular transaction is probably sitting in front of the computer frustrated because they've tried to do something 5 times. Maybe the software didn't blow up on them. Maybe it was just validation errors, but they're trying to do something 5 times and they're frustrated. Do we know that? Okay. And do we have enough telemetry and diagnostics to be able to predict that a downtime event is about to happen or at risk? Some of the client impacts I'll come back to, but I'll go through each one of these layers one at a time. And it all starts in the middle with the automated DevOps pipeline. That's really the core of our capability. And, there's a lot of talk about this, and there's tools coming out. Azure DevOps Services used to be called VSTS. And of course there's JetBrains TeamCity that are providing easier and easier ways to do automated builds and automated testing and other types of validation and automated deployments. Octopus Deploy, the premier deployment server, and Redgate SQL change automation for database DevOps and database change management. And so, but the automated DevOps pipeline, that really is the core of a holistic DevOps-centered software engineering capability, okay? It's not enough, but it's at the core. And that is setting up the infrastructure and the foundation so that we can have an idea. A stakeholder or a product manager can have an idea and then flow that through the system to define it and to determine what the acceptance criteria or the test cases should be, so that when the programmers or developers are coding it, they have all the information that they need. And then there's inspections and code analysis and at least 3 layers of automated deployments with multi-layer test automation. But that capability is at the core. The next layer of this onion here, and it's all dependent. And the more outer rings are dependent on the rings to the center. Okay. The next set of things that we have to have are practices, and they layer onto the automated DevOps pipeline. But if we go counterclockwise, the strategic part of this is determining what our standards are, what practices. It could be the solid principles. It could be a certain set of patterns that we have chosen. It could be the way we have our team operate and communicate. But either way, there needs to be a set of standards, consistency and standards that are determined for the team. Then at the bottom, we see TDD for tester and development. Then we need to faithfully execute those practices in a very consistent manner. And so tester and development is one of those practices where even if it's not followed to the definition, test automation in general has been proven to be very effective at reducing defects. And there's 3 layers of test automation that at a minimum, we need to be implementing: unit tests, component level integration tests, and then full system tests. And of course, the full system tests have to be executed on an environment that is fully deployed. So the continuous integration build, that can run the first 2 sets of test suites, but we actually have to deploy the system onto a production-like environment in order to run full system tests. And these are getting more and more adoption in the industry, although unit tests are pretty well adopted at this point. But then as we go around the ring, what that gives us is discipline. Ongoing discipline is the result. And disciplined teams are going to have better outcomes. Okay, once we determine the practices and we're executing those, and we're keeping track of and measuring the resulting discipline, then we need to turn our attention to defect removal. And there's some research by Capers-Jones that discusses what a level of industry malpractice would be for defect removal. And there's a metric, defect removal efficiency, called DRE, which is probably the most research-friendly metric that we can compare ourselves from a benchmarking perspective with other projects in the research pool that are available to us. And for internal software, 85% of defect removal before production, or 85% DRE, is considered the minimum bar, and anything lower than 85% is, according to Capers-Jones, malpractice. And I think that's a very reasonable assertion, because if we have more than 15% of total defects making it through to production, there's research beds that show average defect rates. A defect is a problem, and it's a problem that manifests itself in production. And certainly when we're writing the code, there can be problems when writing code, but there can also be problems that are created in test definition, in technical design. There could be a defect in the architecture. There could be a defect in requirements analysis, sometimes called a requirements gap. But that's something that went wrong, that wasn't caught. The quality control steps at that particular stage were not adequate, and they did not catch a problem, and that problem went downstream, and it not caught at all, it makes itself to production. Well, now we have something in production that doesn't do everything that it's supposed to do, and users can't do the job. So defects can happen anywhere along the way. There can be problems when deploying. There can be defects in the server configuration. So if you imagine this assembly line of stages in your organization, and every organization is going to have different workstations essentially in the assembly line, but there can be problems that happen at any of these workstations. But defect detection is the strategic element, is determining what are our defect detection strategies going to be. Now, research shows that there are three that, when combined together, very reliably get a team up to 95% defect removal efficiency. And if you're shipping software that other people are embedding into other software, like for instance, Windows or applications that are installed in environments you don't control, the bar is higher. But the three techniques to get you up to 95% or higher are inspections, automated testing, and static analysis. And so those are techniques that we consider a given just because they're supported by research. There's other quality control techniques that need to be put into place as well. But from a strategic perspective, you as the leader of the team need to decide what the defect detection strategy is going to be for the team. And inspections could be something like pull requests. It could be that before you move a card from one swim lane to another, you have someone just look at it and validate the definition of done for that swim lane, for that workstation. Another is testing. In today's world, automated testing is going to be the majority, but you have to have multiple layers of automated testing so that you can cover every type of problem that may manifest itself in the working software. And then the third quality control technique is static analysis. And that is, for example, FXCOP or Independ or SonarQube or JavaScript linting or ReSharper code analysis or duplication finders. Any of these command line tools that can run against the source code or against the resulting assemblies or packages, and they have huge rule sets, and they will call out common problems. And I mean, there's so many that are free. The commercial products are very, very affordable, and they are going to be meticulous about catching everything so that the inspections don't have to focus on, did you follow the coding standard, or did you, in JavaScript, for instance, are you using triple equals versus double equal because of some of those scenarios where you're using JavaScript instead of TypeScript. Your inspections can be more human element and team element focused. But anyway, those three techniques are very reliably, when put together, get you up to 95% defect removal. But you will also probably need some additional ones. So you need to think strategically about that. The result is going to be reduced defects, and on an ongoing basis, you'll be able to do defect reviews and then flow back around to defect detection. If a defect flows through, and when it does, you do a root cause analysis, you figure out why your quality control techniques let it through, and you may need to bring on board an additional quality control technique so that you can further tighten your defect removal capabilities. All right, let's move on to workflow. And the reason that defect removal is closer to the center than workflow, because productivity follows quality. We have to increase our quality before productivity can be improved. If you go after productivity, then inevitably people take shortcuts, and then your quality goes down. When your quality goes down, your productivity goes down. But if you increase your quality, then productivity can also increase. So the strategic element is swim lane definition. That is designing the workstations in your assembly line in a tool like Azure DevOps Services, where you can define a board where cards can move across a board. It is determining what are the right swim lanes and just naming them and determine, okay, what sub team or what role within my team owns this swim lane. And in a traditional sense, if you have people generally in program management, they would be defining what the software should do and coming up with ideas and doing requirements. And then you would have engineers who would be actually doing the technical work to make those ideas come together, but they're still one team. In the DevOps world, you have one team responsible for developing the software so that then other people outside the team can use the software. But the swim lane definitions is the strategic element. And then on an execution perspective at the bottom, we need to make all of this work visible. Now, this is one of the core principles that's outlined in the DevOps handbook, the yellow book, is make work visible as work is flowing through. If something has to be done, it needs to be a card, a ticket, a work item of some sort, and it needs to be there. And not be in email or in chat or have multiple work queues. You need one work queue, and you need to have the process of swim lanes so that you have your software factory modeled out, and then everything needs to be visible at all times so nothing is hidden. And then as a result, you'll be able to derive workflow telemetry and metrics about where the bottlenecks start to crop up and what your throughput is, what your lead time and cycle time, and you'll be able to compare percentile against research in the industry and benchmarks. Once you have decided that, then comes what you're actually building, and this layer about what we're building is blueprints. In any field where you're building something, any field, there is some pictorial representation of what the thing is that's being built, from a storage shed to a house to a car to the software system in the Mars rover. I mean, everything if you can't draw it, if it can't be drawn, it can't be built. So every field, every mature field has pictorial blueprints of some sort, and software is no different. And so the strategic element is the architectural definition. Okay. And in our opinion, the best architectural definition method is the 4+1 architectural blueprints by Philip from Rational Software back to 1995, I think. Search for 4+1 architectural blueprints and you'll find the PDF white paper. But essentially for software, it says that there's 4 layers. 4+1 is 4 layers plus the scenarios or software capabilities. And they're the physical or runtime layer, how the servers are configured. The second layer is logical. Where are the module boundaries? In .NET is where are the project or assembly boundaries, or possibly different microservices. And in the third layer is the process layer. How does data flow through the system when a user executes a common transaction? And then the fourth layer is the structure of the development environment that's necessary to build, modify, or maintain the software. And of course, your particular software may need a fifth layer. And then the +1 is keeping an up-to-date list of high-level capabilities so that the architectural blueprints can be versioned. For instance, if a new major capability comes online, we're going to need to create a new revision of our blueprints because a new architectural element is likely to need to emerge and be added to the system. If I'm just going to add one additional screen that's very similar to previous ones, then that's not a new scenario. We're talking about major capabilities that would cause a new dependency to become part of the system, or for some of the architecture details in the architectural layers to change if a new architectural element is discovered. And then as we're moving along the bottom of the ring, we need to keep those views up to date and keep an eye out for when the architecture does need to change, because we're doing everything in an incremental manner. And at any time we could discover that an architectural element needs to be modified or added. And so we need to keep those views up to date so that everybody can really have the same shared vision of what is being built, because they can all see the same thing. And then what that's going to result is the ability to have periodic walkthroughs, because just like if you're building a skyscraper, you can see that, oh, all the steel is constructed up to floor number such and such, and on the bottom floors we're putting in concrete and sheetrock. And you can actually take the customer, the person who's paying for this skyscraper, you can have them do a walkthrough. Same thing with software. What this does, once you get to this point with the blueprints, it enables you to give somebody a walkthrough even before they can use a particular capability. Now, the features that are ready for it to be used, sure, they're using those software, but they're using those features. But new capabilities where new architectural elements are added, you may have a period of time where you can't use the capabilities just yet, but because you have those blueprints, you can show them, and then you can walk through the different layers and give a more technical demonstration, and even your non-technical stakeholders will be able to follow. All right, the next is cloud operations. And I put cloud in there because in today's world, even if we are in a data center that our company owns, we're using the same premise of public cloud, even in our private data centers, whether it be for VMware, where we're dynamically spinning up and spinning down servers. And even if you're not today, or you have a system that's old and hasn't been modernized, things are going that way in a hurry. But now you have a system, you need to operate it. And observability is the watchword that I talked about. And so the strategic element here is centralized logging. You may have a lot of different pieces running around in this software system that are producing information, writing to log files, performance counters, all kinds of telemetry, and it all needs to be pulled together, or else you have no ability to figure out what's going on. A lot of people have to remote into a server in order to see what's going on with the server, or at least know what all the servers are, so that they can manually correlate them at the same time. And then you're back to your key talent dependency, where maybe only one or two people really know how to put all the pieces together so that they can get a view of what's going on with the whole system. So strategically, centralized logging, the premise is that you identify the telemetry that is being produced. And telemetry is the broad word, whether it be a log file or performance counter or event streaming, any type of information being produced by the running software. One, you need to make sure that every component is producing information, is producing telemetry. And then you need to strategically design a mechanism to have all of that telemetry funneled to the same place, a place where it can be analyzed. In the Azure world, that's log analytics. Log analytics is amazing at being able to absorb all kinds of information and query across it instantaneously. And then in Azure, you can configure certain queries against thresholds for automated alerts down certain communication channels. So strategically, you need to determine what your centralized logging mechanism is going to be. And then on an ongoing basis, you want to have an automated monitoring capability. That is, you are constantly querying all of your aggregated information, your aggregated telemetry. You're constantly querying, and you are alerting when the results of one of those queries crosses a certain threshold. And of course, if there's a critical exception, that's easy. Everybody knows to alert on those things. And if a server goes down, that's easy. But other things like the back button was pressed, a certain number of times within a certain time frame by a certain type of user. You're going to make up what these things are, because anytime a user reports that there's a problem with the software, they're going to say, oh, this is what I did. And then you think, that's the second time that's been reported. let me go and manually look in these logs, and you'll be able to find, oh yeah, there's a lot of people that are having problems, and this is what it looks like in the logs. Then you create a query, then you set up the threshold, and now you have an alert when somebody else does. Of course, you're going back and figuring out what you can change about the system to fix that, but you're incrementally, constantly adding these queries and these alerts. And of course, you're adding them to your Git source control so that they're versioned with the system and deployed and updated in your automated DevOps pipeline. We don't want to have just the source in production. We want to have this type of monitoring happen in all of our environments. And then the result up on the top right is the ability to have formal incident management, where an alert goes off automatically, or if a user reports something, you have the ability to track the incident, communicate the status back to the person who's interested, flow it through a tier structure, tier 1, tier 2, tier 3, if you have that in your organization, and then also be able to derive metrics around mean time to recovery, mean time to response, and build up a knowledge base as well, so that future incidents can be handled in a much more streamlined way. Okay, now the outer ring. Once we have set up our team for success, then we have the ability to start spinning, to go through the DevOps cycle, plan, code, integrate, package, release, operate, and then learn from what we did and do it again. And whether you're starting and your cycles are 3 months or 1 month, you're going to get this cycle down to a day, and a lot of teams get this cycle down within the day. And that may sound radical for some types of software, and of course we hear of companies doing that. But even if you got this cycle down to a week and you were a month or 3 months, think about what your order of magnitude improvement would be. This enables you to increase your effectiveness and your ability to go through a cycle by an order of magnitude. So that's all the layers. Now, in our industry, I think that's comparable to the following analogy. Imagine that you, instead of running a software organization, you are setting up an auto mechanic shop, and you pick out a perfect location, lots of traffic, new shopping center going on. You're going to start up an auto mechanic shop. And so you go to the local auto mechanic school and you say, your next graduating class, I want to hire the top 7% of graduates. I'll factor that into my financial plan. I'm going to pay what it takes to get the top 7%. Only the best will do. Your best educated, smartest graduates, well qualified from the mechanic school. And then you go to the Snap-on tools or whatever tools, you buy all the brand new equipment, brand new tools. It's sitting in the shop in crates, ready to be set up. And then the day comes and your new class of mechanics, really smart people, they come in and you gather around and you say, okay, we're going to open soon. I got all this state-of-the-art equipment. Let me know if I missed something. Only the best will do. Let's get the shop set up so that we can start serving customers. And then they look around at each other and they look at you completely wide-eyed because they were never trained in how to properly set up their shop, set up their own environment. They were trained in a shop that was professionally set up by others. That's the state of our education system when it comes to developers. There's lots of coding schools. There's lots of computer science departments that teach all the individual languages and things like that. But this right here is your challenge. This right here is your job, giving your team the environment and the setup of the shop so that they can be effective. You got really smart, really capable people. Now you want to set them up for success. And that's what this is. This is setting up the shop properly so that your good people can shine. All right. So we went through each one, and you notice that we have some alignment here. On the top left are all of the elements where you need to pick a strategy and the elements of that strategy. The items on the bottom wing within the onion, are what things we need to do on an ongoing basis to execute properly on an ongoing basis. And the top right are the elements of measurement the outputs, the things that we can chart and graph over time to determine our level of effectiveness in this area. And so I talked a little bit about the beginning. We certainly have a practice that where we provide dedicated and build dedicated teams with all of this and that are operated for you. But given that you have a team, you want a self-sufficient or a self-enabled team or human software factory run by you. And so the next steps, if we can help you out, we can help you with project definition, DevOps assessment, software review, or modernization roadmap. In fact, we're about to close the webinar. I'm going to stay on the webinar and enable video or whatnot. But I'm going to stay on the webinar. Use the chat. If any of you would like to talk about any particular thing, I'm happy to give free advice to anyone. This is my direct phone number, email, Twitter account. I appreciate everyone's time. I know it's valuable. I try to target the shorter webinars. We don't need to take a full hour in order to get through this information. You got busy schedules. But in the chat window, what I'd like to do is give me a signal. If you want to take just 10 minutes or more, and you would like a personal phone call to talk about a particular project, and you just want some more advice, I'd be happy to do that. Just put it in the chat, and then we can connect over phone immediately after closing this webinar down. And while that's happening, there's a Q&A window, and if there's any questions, we can handle those right now. Okay, so one of the questions is, do you have to have all of the layers in place before you can do your first iteration? And I would say, obviously, no. You can start iterating right now. You can start thinking, oh, I need a software feature. Let me write some code. I don't have any architecture in place, but I'm going to have a website with no database. Well, you know what? In 5 minutes, you've chosen your initial architecture and you're writing some spike code. I mean, you can do that. But the most effective thing to do is to use just a few hours and put in, with the 80-20 rule, use 20% of the time and put in as much of each of these layers as you can in a few hours right away, just to get the definition going. And if you have a team and ready to rock, don't have them sit on their hands. Just have them start working, while at the same time you determine the missing strategies of each of these layers of DevOps and get them in place. But you will be essentially changing the tire or changing the oil and improving it while the bus is running. So, well, thank you all very much, and have a great day.